Hello students, welcome to Breedmark Academy. Myself LS Nanda. Now in today's video, I am going to discuss the solution of a mathematics question that was asked in one of the shifts of JEE Main 2025 April session exam. It says let f of x equal to log of 8 minus log of x square plus 5x plus 6, where the base of these logarithms are 2, 3, 7 and 2 respectively, where x is less than minus 3, has domain open interval alpha comma beta, and g of x equal to sine inverse of 2x square plus x plus 1 whole divided upon 3x plus 5, has domain closed interval gamma comma delta. Then the value of alpha square plus beta square plus gamma square plus delta square is equal to. Now students, basically in this question, we have to find the domains of the functions f of x and g of x. From there, we will get the values of alpha, beta, gamma and delta, and hence find the value of the required expression. Now students, in order to solve this problem, you must know that the domain of a logarithmic function is found by keeping its input as positive. Now since f of x is a composite function, it involves 4 logarithmic functions. So that means in order to find the domain of f of x, we will have to keep the inputs of all of these logarithmic functions as positive. Now for the sake of convenience, I am naming these logarithmic functions as 1, 2, 3 and 4. Now if I consider the input of the fourth logarithmic function, that is x square plus 5x plus 6 as positive, then I get x plus 2 inside the bracket into x plus 3 inside the bracket greater than 0. Now when I apply wavy curve method, I get x less than minus 3 or x greater than minus 2. Now students, we have been given that x is less than minus 3. So that means the first interval of x is accepted and the second one is rejected. So it means x belongs to open interval minus infinity to minus 3. But this is not the domain of f of x. To find the domain of f of x, we will now have to keep the input of the third logarithmic function as positive, then the input of second logarithmic function as positive, and finally the input of first logarithmic function as positive. And then we will have to find the intersection of all of these intervals of x obtained from these conditions. And that will finally become the domain of f of x. But this is a long process. Now to make it shorter, what I am doing, I am starting with the first logarithmic function. That means I am taking the input of first logarithmic function, that is log of 8 minus log of x square plus 5x plus 6. As positive. Now you will just see, when I consider the input of first logarithmic function as positive, then the input of second logarithmic function and the input of third logarithmic function obviously become positive. So that means straight away by putting the input of the first logarithmic function, our work is done. Now students, from here I can write log of 8 minus log of x square plus 5x plus 6 is greater than 3 to the power 0. Now 3 to the power 0 is 1 and 1 we know is greater than 0. So that means the input of second logarithmic function has become positive. Fine. Now in the next step I can write 8 minus log of x square plus 5x plus 6 greater than 7 to the power 1, which is just 7. Now 7 is also positive. So that means the input of third logarithmic function has also become positive. Now students, we will solve it further. It becomes log of x square plus 5x plus 6 to the base 2 less than 1. Now students, we move further. Now students, we have to solve the inequality log of x square plus 5x plus 6 to the base 2 less than 1. So this means x square plus 5x plus 6 is less than 2 to the power 1, and that is 2. So this becomes x square plus 5x plus 4 less than 0. From here we get x plus 1 inside the bracket into x plus 4 inside the bracket less than 0, and we get x greater than minus 4 but less than minus 1. Now earlier we had x less than minus 3. So if I take the intersection of both of these intervals, then I get x between minus 4 and minus 3. So that means the domain of f of x is open interval minus 4 to minus 3. But it is given to us as open interval alpha comma beta. So by doing comparison, we get alpha as minus 4 and beta as minus 3. Now students, we find the domain of the function g of x. Now g of x is given as sine inverse of 2x square plus x plus 1 whole divided upon 3x plus 5. Now to find the domain of the function sine inverse x, we know that the input of sine inverse function must be lying between closed interval minus 1 to 1. So that means 2x square plus x plus 1 whole divided upon 3x plus 5 will be greater than or equal to minus 1 and less than or equal to 1. Now students, I will break this inequality into two parts. The first one is 2x square plus x plus 1 divided upon 3x plus 5 greater than or equal to minus 1, and the second is 2x square plus x plus 1 divided upon 3x plus 5 less than or equal to 1. We will solve both of these inequalities and finally find the intersection of the intervals of x which we get from them, and that will give us the domain of the function g of x. Now when I consider the first inequality, I get 2x square plus x plus 1 divided upon 3x plus 5 greater than or equal to minus 1. Now let's solve it. Now students, this inequality can be written as 2x square plus x plus 1 whole divided upon 3x plus 5 plus 1 greater than or equal to 0. This becomes 2x square plus x plus 1 plus 3x plus 5 whole divided upon 3x plus 5 greater than or equal to 0, or 2x square plus 4x plus 6 whole divided upon 3x plus 5 greater than or equal to 0. Now divide both sides of this inequality by 2. So you will get x square plus 2x plus 3 whole divided upon 3x plus 5 greater than or equal to 0. Now students, the expression x square plus 2x plus 3 is positive for every real value of x. Why? Because we know that whenever the coefficient of x square in a quadratic polynomial is positive and its discriminant is negative. Now here the discriminant of x square plus 2x plus 3 is 4 minus 12, which is minus 8. It is negative. So then in this condition, the quadratic polynomial is strictly positive. So that means I can divide by x square plus 2x plus 3. So I will get 3x plus 5 greater than 0. Because if we are having a fraction whose numerator is always positive and we want that fraction to be greater than or equal to 0, then obviously the denominator must also be positive. Now from here we get x greater than minus 5 upon 3. Now students, I am calling this inequality as inequality number 1. Now we consider the second part of the main inequality, and that is 2x square plus x plus 1 whole divided upon 3x plus 5 less than or equal to 1. So just bring 1 onto the left hand side. It becomes minus 1 less than or equal to 0. Now students, this can be written as 2x square plus x plus 1 minus 3x minus 5 whole divided upon 3x plus 5 less than or equal to 0. So from here we get 2x square minus 2x minus 4 whole divided upon 3x plus 5 less than or equal to 0. Now we move further. Now students, divide both sides of this inequality by 2. So you will get x square minus x minus 2 whole divided upon 3x plus 5 less than or equal to 0. Now this can be written as x minus 2 inside the bracket into x plus 1 inside the bracket whole divided upon 3x plus 5 less than or equal to 0. Now apply wavy curve method. This is minus 5 upon 3, this is minus 1, and this is 2. This is positive, this is negative, this is positive, this is negative. Now we want the expression to be less than or equal to 0. So that means these two regions satisfy the condition. So x belongs to open interval minus infinity to minus 5 upon 3 union closed minus 1 to 2. Now students, I am calling this interval as second interval. Now the first interval is x greater than minus 5 upon 3. Now when we take the intersection of both of these intervals, we get x belonging to closed minus 1 to 2. So that means the domain of the function g of x is closed minus 1 to 2. Now just make the comparison. You will get gamma as minus 1 and delta as 2. So that means the value of the expression alpha square plus beta square plus gamma square plus delta square becomes 16 plus 9 plus 1 plus 4. And this becomes 25 plus 5, which is 30. So this is the correct answer of this question. Now students, next question I will be posting in tomorrow's video. Till then, goodbye. Keep watching my videos and enhance your knowledge of mathematics. Thanks.